Look up at the night sky. On a clear night, far from the bright lights of our cities, you can see it. A river of stars spills across the darkness, a breathtaking tapestry of light and shadow. For as long as we have been human, we have stared into this cosmic ocean with a sense of profound wonder. What are those lights? How far away are they? Are we alone in this immense darkness? These are not new questions. They are as old as our species, whispered around ancient campfires and pondered by the earliest civilizations. This curiosity is part of what makes us who we are, a deep-seated desire to understand our place in the grand scheme of things. It is a pull, an instinct to explore beyond the horizon. This innate drive to explore has defined our history. It led our ancestors to cross vast oceans. It led our ancestors to climb the highest mountains. It led our ancestors to venture into the most remote corners of our planet. We are an inquisitive species, never content with the familiar. The greatest adventures of humanity have always begun with a simple question: what is over there? The universe represents the ultimate frontier, the final, seemingly endless ocean to cross. Its sheer scale is almost impossible for our minds to grasp, yet that has never stopped us from trying. The desire to know what lies beyond our world is a powerful force, one that has shaped our science, our philosophy, and our very identity. The universe does not give up its secrets easily. It is a place of extremes, of unimaginable distances and timescales that dwarf a human life. It is filled with serene beauty. It is filled with violent, cataclysmic events. Yet we are not deterred by the scale of the challenge. Instead, we are inspired by it. Every new discovery, every new image sent back from a distant probe, only deepens our fascination and fuels our hunger for more knowledge. We build bigger telescopes and design smarter spacecraft, all in service of this fundamental quest. The story of our species is a story of exploration, and the exploration of space is its most ambitious chapter yet. It is a journey we are all on together. From the first person who charted the movement of the stars, to the engineers now designing missions to distant moons, the motivation remains the same. We want to understand the cosmos and our connection to it. We look at the stars and see not just points of light, but destinations. We see possibilities. We see the potential for answers to our deepest questions about where we came from and where we are going. This journey into the universe is more than just a scientific endeavor. It is a profoundly human one. It is the continuation of a timeless quest that began the first time a human looked up and wondered what was out there among the stars. Our solar system is our home, our immediate cosmic neighborhood. It is a place of incredible diversity, anchored by the familiar glow of our sun. Closest to this star are the rocky terrestrial planets: Mercury, a scorched and cratered world of extreme temperatures; Venus, shrouded in a thick, toxic atmosphere that creates a runaway greenhouse effect, making it the hottest planet; Earth, a vibrant blue oasis teeming with life; Mars, the red planet, a cold desert world with towering volcanoes and deep canyons, holding tantalizing clues that it may have once been warmer and wetter, perhaps even hospitable to life. Moving outward, we cross the asteroid belt, a vast ring of rock and debris that marks the boundary to the outer solar system. Here, the gas giants reign supreme. Jupiter is the undisputed king, a colossal ball of hydrogen and helium so massive that it could contain all the other planets combined. Its swirling bands of clouds and the Great Red Spot, a storm larger than our entire planet, are a testament to its violent and dynamic nature. Next is Saturn, famous for its breathtaking system of rings, a delicate and intricate structure made of countless particles of ice and dust. It is a jewel of the solar system, a world of ethereal beauty and scientific wonder. The journey continues into the deep cold, to the ice giant Uranus. Uranus, tipped on its side, spins at an extreme angle, giving it the most unusual seasons in the solar system. It is a pale blue-green world, enshrouded in a hazy atmosphere. Neptune, a deeper, more vibrant blue, whipped by the fastest winds in the solar system. This remote and stormy world marks the edge of the planetary region. These distant giants remind us just how vast and varied our own solar system is, with each planet being a unique world with its own story to tell. Beyond the orbit of Neptune lies a mysterious and frozen frontier known as the Kuiper Belt. this is the realm of dwarf planets like Pluto, once considered our ninth planet, now revealed to be the largest member of a swarm of icy bodies. These are the forgotten relics from the formation of our solar system, preserved in the deep freeze of outer space for billions of years. Our robotic explorers, like the New Horizons spacecraft, have given us our first tantalizing glimpses of these distant worlds, revealing icy mountains and frozen nitrogen plains. Our cosmic backyard is far larger and more complex than we ever knew, filled with wonders that continue to challenge our understanding. For centuries, we could only wonder if other stars had planets of their own. Our solar system was the only example we had, a single data point in an ocean of cosmic uncertainty. We looked at the countless stars in the night sky and asked a simple, profound question. Are there other Earths out there? The idea of exoplanets was a staple of science fiction, but finding them seemed impossible. These worlds were faint and lost in the glare of their stars. Detecting them was one of astronomy's greatest challenges. Everything changed with new detection methods and powerful space telescopes. Astronomers learned to spot telltale signs. One is the tiny, rhythmic wobble of a star. Another is the minuscule dip in brightness, a transit. Missions like Kepler stared relentlessly, monitoring hundreds of thousands of stars, waiting for faint planetary signals. Results: a revolution. From 0 to thousands confirmed. The universe is teeming with worlds. Hot Jupiters, super-Earths, rogue planets. Planetary systems very different from ours. Data says planets are the rule. Likely more planets than stars in our galaxy. The ultimate goal? Find a world like our own. A small rocky planet in the habitable zone. A place where liquid water can exist. We're on the verge of analyzing atmospheres, searching for chemical signatures of life. Oxygen, methane. The hunt is about finding our place in the cosmos. About answering, are we alone? The echoes of other worlds are getting louder every day. Stars are the engines of the cosmos. They are the great furnaces that forge the elements necessary for life. They bathe the universe in light and warmth. Our own sun is a star, an average, middle-aged star. It provides the energy for everything on Earth. But stars come in a spectacular variety of sizes, colors, and ages. There are small, cool red dwarfs that will burn steadily for trillions of years. And there are colossal blue giants, massive and intensely hot stars. They live fast and die young, burning through their fuel in a few million years before exploding in brilliant supernovae. Stars are not born in isolation. They form within vast, cold clouds of gas and dust, known as nebulae. These stellar nurseries glow with vibrant colors. Intense radiation from newborn stars illuminates the surrounding gas. Within these cosmic clouds, gravity slowly pulls clumps of material together. As clumps grow denser, pressure and temperature at their cores rise. Eventually they become hot enough to ignite nuclear fusion. At that moment, a new star is born, shining out from its dusty cocoon. Imagine, if you will, a star many times more massive than our sun, reaching the end of its life. After burning through its nuclear fuel for millions of years, the outward push of energy that supported it finally ceases. In that instant, gravity wins the long battle in the most spectacular way possible. The star's core collapses under its own immense weight with unimaginable force. This collapse is so extreme and so complete that nothing, not even the fundamental forces of nature, can stop it. The core is crushed down into an infinitely small, infinitely dense point called a singularity. This catastrophic event gives birth to a black hole. A black hole is a region of space-time where gravity is so strong that nothing can escape, not even light itself. This is why they are called black. The boundary of no return is called the event horizon. Once anything crosses this threshold, a stray asteroid, a cloud of gas, an entire star, it is lost forever, pulled inexorably toward the singularity at the center. We cannot see a black hole directly, since it emits no light of its own. Instead, we must infer its presence by observing its profound effects on its surroundings. We can, for example, see stars orbiting a patch of empty space at incredible speeds, or watch as material is pulled from a companion star, forming a superheated disk of matter that glows brightly before it vanishes. For a long time, black holes were purely a mathematical concept, a strange prediction of Einstein's theory of general relativity. They seemed just too bizarre to be real. However, decades of astronomical observations have provided overwhelming evidence that they are not just real, but actually common throughout the universe. When a massive star dies in a supernova explosion, its fate is not always to become a black hole. If the star is massive, but not quite massive enough to trigger a complete collapse into a singularity, the entire core is compressed into an object only about 20 kilometers across, roughly the size of a city. What is left is a neutron star. The density of a neutron star is almost beyond comprehension. A single teaspoon of its material would have a mass of about 1 billion tons, which is equivalent to the weight of a mountain. Some neutron stars, known as pulsars, can rotate hundreds of times every single second. As the star spins, these magnetic fields channel beams of intense radiation out from the magnetic poles. If one of these beams happens to sweep across our line of sight as the star rotates, we see a regular pulse of radiation, like a cosmic lighthouse. This act of destruction is also an act of cosmic creation. The heavier elements essential for planets and life were created inside stars. But only in the unimaginable heat and pressure of a supernova can the very heaviest elements be formed: gold, silver, platinum. Supernova are the great cosmic forges that enrich the universe. The aftermath is a beautiful, expanding cloud of gas and dust called a supernova remnant. This is the great cosmic cycle of death and rebirth. The death of one star provides building blocks for countless others, and potentially for life itself. We are, in the most literal sense, made of stardust. The iron in the hemoglobin that carries oxygen through your veins was created in a supernova billions of years ago. When we look out at the universe, we are looking at our own cosmic origins. While telescopes allowed us to look, our restless spirit drove us to go. The 20th century saw humanity take its first tentative steps off our home planet. They were the first humans to see our world as it truly is. A fragile, beautiful blue marble suspended in the vast blackness. The images of Earth rising over the lunar horizon had a profound impact on human consciousness. They inspired a sense of unity and a greater appreciation for the delicate environment of our world. The journey to the moon was a journey of discovery, not just about another world, but also about our own. Our exploration did not end with human footsteps on the moon. We began to send robotic explorers as our eyes and hands throughout the solar system. We have landed rovers on the surface of Mars, which diligently search for signs of past life in the red dust. We have sent probes to fly through the majestic rings of Saturn and to dive into the turbulent atmosphere of Jupiter. These robotic ambassadors have given us close-up views of volcanic moons, icy worlds with hidden oceans, and asteroids that are relics from the dawn of the solar system. Each mission pushes the boundaries of engineering and expands the frontiers of our knowledge, painting a more detailed picture of our cosmic neighborhood. Today, we stand on the cusp of a new era of exploration. We are planning to return humans to the moon, this time to stay. We are developing the technologies that could one day take astronauts to Mars and beyond. We are no longer just observers of the cosmos. We are active participants, voyagers setting out to explore the vast expanse. The great unknown still calls to us, and the adventure is only just beginning. The sheer scale of interstellar space is the single greatest barrier we face. Our nearest stellar neighbor, Proxima Centauri, is over 4 light-years away. With our current rocket technology, a journey there would take tens of thousands of years. It is a distance so vast it seems insurmountable. To cross the gulf between stars, we need a complete revolution in our understanding of physics and engineering. One idea is to use light itself for propulsion. A powerful laser beamed from Earth would push on this sail, accelerating a tiny, lightweight probe to a significant fraction of the speed of light. Projects like Breakthrough Starshot are actively developing this technology, sending a swarm of nanocraft to Proxima Centauri. A journey that would take just over 20 years, rather than millennia. Other, more speculative ideas push the boundaries of known physics even further. concepts like warp drives propose bending or warping the fabric of space-time itself. Reaching for the stars is the ultimate expression of our exploratory spirit, a journey that will define the future of humanity. As we grapple with the immense scale of our own universe, some scientific theories suggest that it may not be the only one. This is the mind-bending concept of the multiverse. It proposes that our universe could be just one bubble in a vast cosmic foam of countless other universes. Each of these other universes might have its own unique set of physical laws, its own fundamental constants, and perhaps even different dimensions of space and time. One version of this idea comes from a theory called eternal inflation. It suggests that the Big Bang that created our universe was not a one-time event. Instead, new universes might be constantly budding off from one another. This could help explain a deep puzzle about our own existence. Why the fundamental constants of nature in our universe seem so perfectly fine-tuned to allow for the formation of stars, planets, and ultimately, life. Our galaxy, the Milky Way, contains hundreds of billions of stars. We now know that most of these stars likely have planets. It seems almost inevitable that life should have arisen elsewhere. If life is common, somewhere out there, intelligent life must have evolved. This leads to the Fermi paradox. If the galaxy should be teeming with intelligent aliens, then where is everybody? We are met with a great cosmic silence. For decades we've been listening for signs of intelligent life beyond Earth. This effort is called SETI. Astronomers hope to pick up signals clearly artificial in origin, a narrow-band transmission, a repeating pattern, a complex message. Despite decades of searching and scanning millions of star systems, we've found nothing. The silence from the stars is deafening. Just as we ponder the universe's beginning, we are also driven to ask how it will all end. The answer depends on a cosmic battle between gravity and dark energy. We learned the universe's expansion is accelerating. Dark energy appears to be winning the battle against gravity. This scenario is called the Big Freeze, also known as heat death. As expansion accelerates, galaxies will be pulled away, crossing a cosmic horizon and disappearing from view. Within our merged galaxy, star birth will cease. Existing stars will burn out one by one, leaving a graveyard of black dwarfs, neutron stars, and black holes. Even these remnants won't last forever. Over incomprehensible timescales, black holes slowly evaporate via Hawking radiation. Eventually, the last black hole radiates away, leaving a faint, cold mist of elementary particles. This is ultimate heat death. The cosmic story that began with a brilliant flash ends in eternal darkness. Our journey has taken us from our home planet to the edge of the observable universe and into the realm of radical ideas. After such a vast cosmic tour, we are drawn back to a single poignant image, the Voyager 1, pale blue dot photograph, showing Earth as a single, tiny point of light. From the cosmic perspective, our world is but a lonely speck in the great, enveloping dark. On this tiny dot, and nowhere else that we know of, the universe has become conscious. All our history, all our triumphs and tragedies, our art, our science, and our love, have unfolded on this fragile stage. The stardust forged in ancient fiery supernovae now forms the ground beneath our feet and the very substance of our being. We are not separate from the universe. We are intrinsically connected to it, woven from the same cosmic fabric. This realization changes our relationship with the night sky. It is no longer a distant alien realm, but our ultimate home and our origin story. Science is not a book of answers. It is a method of asking better and better questions. It is driven by curiosity, imagination, and a refusal to accept "we don't know" as a final answer. Our knowledge is like an island in a vast ocean of the unknown. The more we learn, the more we realize how much we have yet to learn. The future of our cosmic destiny is a choice we must make together. The journey into space has always brought out the best in humanity, our ingenuity, our courage, and our ability to work together. The universe is a place of breathtaking beauty, profound mystery, and infinite possibility. It is our past, our present, and our future. The story is far from over. In many ways, it has only just begun. As long as we keep looking up with a sense of wonder, humanity will have a grand and noble purpose. The universe is full of wonders waiting to be discovered. Subscribe to Kendu Global Files for more 20-minute documentaries that take you to the edge of knowledge and beyond.